Hey, hello everyone. So today we are going to solve LeetCode 23, which is merge k sorted lists. So, okay, the question says that you are given an array of k linked lists. Okay, there are k linked lists. Okay, k number of linked lists in a list. Each linked list is sorted in ascending order. So this is a terms and condition that we have k number of linked lists in a list, and each lists are sorted in an ascending order. Merge all the linked lists into one sorted linked list and return it. So I have to merge all of this linked list in a list and return into a one sorted linked list. This is the question. All right. So as we already know that majority of this K kind of questions are slightly linked with the priority queue data structure in reference. This is a categorization of problems, and if we jump into the solution, how we are going to solve this, it is something to be looked into that we have list, and this is an example of the given list. Okay, and we have also been given the kind of list node defined here, which is val next, and these are two other parameters in the list node. So this is the list 1, 2 and 3. So in order to solve this, we will define priority queue. So priority queue data structure, which will be of list node, and I have to define here it will be minHeap, since we need the smallest element among the nodes in the top of the root node of the heap data structure. So this will be new priority queue, and here we will define the kind of comparator that we need, which is p comma q for minHeap. Basically we will define as p dot val minus q dot val, particularly vice versa would be the maxif definition of comparator key here being passed to this priority queue. Okay, all right, yes. So this is the minHeap, and we have lists, so we will just iterate the list. So for lists are basically uh, list node node with lists. We will iterate this and we'll get each node, and we will just put the node dot add node. All right, and so we will all add all the nodes in the minHeap one by one. So basically here we have to understand the fundamental of the linked list, that whenever we are iterating this list which contain a k number of linked lists, we are adding each root node to this minHeap data structure. So this minHeap data structure basically contains the first example 3 nodes, out of which the root node will have 1, the left node will have 1, and the right node will have 2. So this will be the structure how it will look like for the minHeap. And so we have the root node of each linked list, and that root node basically contains the address of all the subsequent linked lists. So now we have this priority queue being organized, and now we will have a looping for while minHeap is minHeap is dot is not empty, and here we have this condition, and inside that we will check that um, we will have, suppose, one list node which will be dummy, and new list node which will contain 0 value, since we have to define the parameter value here. So we will be calling this constructor here, so it contains 0 node. And suppose we have list node as current to, which is pointing to this dummy, so we will just use this, we won't change the initial dummy list node, and we will just update the current node in our calculation return based on that. So here we are, and we will just see if minHeap is not empty. We will just take one more list node node which will minHeap dot poll, and it will give me the node, and then I will just check if node dot next is not equal to null, it means we can just add the subsequent other um, values of this node of a linked list into the minHeap dot add node dot next, and based on that we have node and the current dot current is dummy, current dot next is equal to node, and current is equal to current dot next, isn't? So I have the current which is pointing to dummy, so I will just make changes in the current, and the current dot next will be so current is dummy, which is this 0. The current dot next will be this new node, and this new node dot next will be in the min heap, and this current dot next contains the new node, and the current also contains the current dot next. Okay. Now current is the current dot next, and which we will again update with the new node from the min heap. And min heap root node will always contain the smallest element among the all other nodes that are in the heap. So this is a functionality of heap data structure, which is of 2-point max heap. All right, so here we just return, what will we return? So we have this current which is in dummy, so we return dummy dot next, which will be basically current. All right, so this is how it is. I think it should work. It's a runtime error, and we see that it is null pointer. Okay, we can just check. Here are empty values, that if node is not equal to null, it will eventually add it into the min heap. All right, this is accepted with all of the 3 test cases. So this was a hard problem categorized for sorting, for merging k-sorted lists. Eventually, it is not hard. It will be categorized as medium if we use the priority queue. So this was an efficient usage of priority queue data structure, and also the understanding of the moment we add the first root node of, I mean, the moment we add the list node into the heap, we basically add the first node of the linked list, not the entire list. So the first node basically contains the addresses of the subsequent next node, and which contains the address of next node. So the heap will basically look like for the given 114. For the given these 3 linked lists, the heap will basically look like 1, and then this 1 will contain on the left part as another 1, and on the right part as 2. And so this will basically, and when we will pop this min heap, so it will just pop the first element, which is the root element, and again then when we will pop it, so it will pop this 1, and we will put into the min heap 1 dot next, which is 4. So in the next time it will be 142, and the min heap automatically rebalances, and the value will, after pushing the new value, it will rebalance it to 2, and the 2 will become 4. So this is how min heap works, and again we will pop the first smallest element from this min heap, and in this way we will basically merge the 3 sorted linked lists into the new linked list, and we will return the output. So thank you for looking into this solution. See you in the next problem.